last video we saw creating and insertion in B tree, and in this video we will see deletion in B tree. As we discussed in the previous video, if order of the tree is 5, then m is equal to 5. Maximum number of keys that a node can have is m minus 1, that is 5 minus 1 is equal to 4. Minimum keys can be 2 because 2 in the bracket m by 2 minus 1. Minimum children that a tree can have is m by 2, that is 5 by 2 is equal to 3. 3 because we take ceiling. Maximum children that a B tree can have is 5. Here I will be taking the example of B tree of order 5, and the key which you are going to delete, we will call it as a target key. If you want to delete any key from the B tree, there are two possibilities. Either the target key is in leaf node or the target key is in internal node. First we will see how to delete a key in a leaf node. Again, there are two sub cases while deleting a key from a leaf node. First case, the target key is in the leaf node and that leaf node contains more than minimum number of keys. And second case, the target key is in the leaf node and that node contains exactly minimum number of keys. Let's first see the first sub case. This is the example B tree I am going to take for deleting the target key. Suppose we are going to delete key 74 out of this tree. First thing we have to do is search where is 74 located in the given tree. Searching will be done from the root node. 74 is greater than 60 and less than 90. So we'll search in this part. Here 74 is greater than 70, less than 80. So we'll go to this part. Here we got the key that we are looking for. Now see, the target key is in the leaf node. Also this node contains more than minimum number of keys. That is more than 2 keys. So here we have to just simply delete the target key from the node. After deleting the target key, the node is still having 2 keys. It means this satisfies the property of B tree. This was simple case, no need to do anything additional. But what if we have to delete a key whose key is in leaf node and node has minimum number of keys? Let's say for example we have to delete 33. Now search where is 33 located. We will begin with the root node. It is a less than 60, so goes to the left subtree, and it is greater than 30, so this side. And here we found the target key, but we cannot simply delete this key. Why? Because if we delete this key, the remaining key in this node will be 1, and that will violate the property of B tree. The property of B tree says every node in a B tree has minimum 2 keys except the root node. In such cases, we can get the again 3 possibilities. First one, the node can borrow the key from the immediate right node or immediate left node if the immediate left or right node has more than minimum number of keys. Here this node does not have right immediate node, so it will request to the left immediate node. The left immediate node can give the key because it is having more than minimum number of keys in a node, but one cannot directly borrow from here because the rule is that it can only borrow through parent node. From the immediate left node, the maximum key value will be transferred to the parent node. Here the maximum key in the node is 26. So 26 will be transferred to the parent node. Now in the parent node, the maximum key is 30. Again that will be transferred to the target key. Now we will delete the target key and update the tree. Now we will see the other possibility where we will have to borrow a key from right immediate node. Say for example we want to delete 82. Now search for the key 82 in the tree. We will begin with the root node. 82 is greater than 60 and less than 90, so it goes here. It is greater than 80, so goes here. And here we found 82, but we cannot delete it simply because it is having exactly minimum number of keys. And if we delete a key from this node, it will violate the property of B tree. So we will check for the immediate right or left node to borrow the key. And here we can see that the immediate left node is also having exactly minimum number of keys. So we cannot borrow from the left node. So it will request to the immediate right node. And here the immediate right node of the target key is having 3 keys. That is more than minimum number of keys. So it can give the key to the target key. But as we discussed, we cannot borrow it directly. While we are borrowing from the immediate right key, we will transfer the minimum value key to the parent node. And again from the parent node it will transfer to the child node. So here the minimum value is 87. Therefore it will be transferred to the parent node. From the parent node 85 will be transferred to the child node. Now we can delete 82. This was second case. Third case is when there is no chance to borrow key from immediate right or left node. Let's see how we can tackle that. It can be done by merging. Let's say for example we have to delete 75. It is greater than 60 and less than 90, so goes here, and it is greater than 70, so goes here. Here we found the target key, but we cannot delete it because it violates the B-tree property if we delete one key here. Why? Because it is having exactly minimum number of keys in a node. Neither we can borrow from the immediate right node nor from the left node, because even they are having exactly minimum number of keys. So in such cases, we will merge the nodes along with the parent node and then delete the target key. Here I am merging the target key with the immediate left node. So the node will become 61, 62, 70, 75 and 78. 70 we are borrowing from the parent node. Why 70? Because it is the common parent key of the target key and left node with which I am merging. So now we will delete 75. After deleting, the tree would look like this. This satisfies the property of B tree. So still it is a B tree. Now suppose we have to delete 30. First find out where is 30 located in the tree. To the left of 60 and to the right of 26. Here we found the target key. It is the leaf node, but it is having minimum number of keys and it does not have immediate right node, and in the immediate left node we have only minimum number of keys, so we cannot borrow. Now the target key node will request to the parent node, so the parent node will send maximum key value down and merge the siblings. Here the maximum key is 26. It will come down to the target key and merge with the sibling. Now the node will become 24, 25, 26, 30 and 37. Now we can delete the target key 30. After deleting the target key, the tree would look like this. But only 20 will remain in the parent node. Because the parent node is having only one key in the node, it will violate the property of B tree. Every node of B tree must have at least two minimum number of keys except the root node. So the parent will ask its left or right subtree for a key. But it is not having left subtree. So it will ask to the right one. But right one is also having only two keys. In such case, it will ask its parent node, and key from the parent node will come down and merge the nodes. Here 60 will come down and will merge with the sibling. So the node will become 20, 60, 80 and 87. In the right side, the tree will remain same as it is. So till now we discussed the scenario where target key was in leaf node. Now we will see how to delete a key when it is in internal node. Internal node means that a node having both its left and right child node. Now we will see how to delete a target key if the key is in internal node. Again here we will come across three cases. First is in order predecessor having more than minimum number of keys. Second is in order successor having more than minimum number of keys. Third case is when in order predecessor and successor having less than minimum number of keys. We will see all these three cases one by one with an example. So now we will try to delete 80 from the tree. Now search for the 80. 80 is less than 90, so goes to the left subtree. And here we found the target and 80 is the internal node. You can choose either in order predecessor or in order successor. How to choose? What will be the in order predecessor for 80? In order predecessor would be the maximum number in its left child node. So the maximum element in the left child node of the 80 is 78. We have to check if the left child of the target key is having more than minimum number of keys. If child node has more than minimum number of keys, then only we can replace the maximum key of the child node with the in order predecessor. Now delete the 80 and replace the number with its in order predecessor. Now the remaining number of keys are 3, so it satisfies the property of B tree. Next, suppose if we want to delete 105. Let's see how to do it. We have 105 to the right of 90. First check if we can replace 105 with its in order predecessor, and we cannot do it because it is having exact minimum number of keys in its in order predecessor. Now check for the in order successor. So in the in order successor of the target key would be minimum key in the right subtree, that is 113. So in order successor is having more than minimum number of keys. It can be replaced with the target key, and here we delete 105 and replace it with 113. Next, suppose we have to delete 87 and the predecessor of 87 is 85, but we cannot replace it because it's having exactly two keys. So we will check in order successor, and in order success for the target key is 88, but we cannot replace it with target key because this node is also having exactly 2 number of minimum keys. So in such cases we will merge the nodes. So here we merge 83, 85, 87, 88 and 89, and then we will delete 87. So it satisfies the property of B tree. So this is how we solve the third case. Please like the video, subscribe to our channel, and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below, and thank you for watching.